Hi, I'm Shubham, and welcome to Applying Machine Learning to Construction. I'm Shubham, and today with me is Charis Kaskiris. Charis has experience working on machine learning and AI models for NASA and has applied that experience to other industries like economics. Sorry, I'll be serious. Yes. So Haris has experience working with NASA, and he has built AI and machine learning models for that. He has applied that to the gaming industry and the advertisement industry, and now brings that expertise to construction. I, on the other hand, like to say that I'm a third generation construction person. I brought my construction hat. And my grandfather used to work in construction. He pretty much worked for the same company. My dad has worked his entire life for the same company in construction. And now I have a master's in data science from Berkeley, but I make machine learning models for construction. So I like to say I work in construction. They don't agree with me. So today we'll be talking about a little bit about what is Autodesk and what is BIM 360 IQ. That's the product we work on. And also talk about some very common problems that every data scientist faces is not having labeled data. And then talk a little bit about our data science strategy and how we leverage Spark in our production workflows. So at this stage, I have a question. How many of you have heard of the Tesla Model X? How many of you have heard of the Shanghai Towers? The Shanghai Tower. How many of you have heard of the movie The Martian? All those three products are designed using Autodesk software. So Autodesk is in three big industries: manufacturing, which is things like cars and chairs; in media and entertainment, so movies like The Martian or the dragons in Game of Thrones are designed using our software; or the third big one is construction. And in construction, this is what was happening in the 1930s. This is the Manhattan skyline. The skyline is building, construction was booming, and this is kind of what's happening today. So it's still very similar ideas. You build a steel structure, then you wrap it around with a glass wall. And whereas this is what automobiles used to be like, and this is what they're like today, completely transformed. They're connected, they share data, they're self-diagnosing, they receive over-the-air updates. I wish my buildings did that. So why do we think at Autodesk that we are the right people to work on this problem of making construction smarter, of applying machine learning to construction? It's because we understand construction really well. So we have been in construction, we have been making softwares for construction for the last 30 years. Our software covers the entire life cycle of construction. So we have softwares that are used by architects and engineers to design buildings. We have softwares that are used by project managers and superintendents to make buildings. And then we have projects that are used by building operations specialists to operate a building. So we cover the entire spectrum. And we really understand construction data. So here you see someone using our software BIM 360 field on a job site for performing checklist. We understand construction data related to 3D models, to point clouds with images, text documents, numerical data. So we understand construction data really well. And because of that, we last year started with, so these are the four big verticals, four big quadrants of construction. There's quality, safety, schedule, and cost. So last year, IQ started with a focus on quality. And now we are venturing into safety, schedule, and cost. So the question is, what does IQ do? What are some of the customer problems that IQ solves? So this is for a project engineer on a construction project. This is something that they have to deal with. They have thousands of quality issues that they have to deal with every day. And you can think of these quality issues as like Jira tickets or software bugs. So there are thousands of these that they have to deal with every day. And the question we ask is, what can we do to help them? So what we do for them is, we have machine learning models that understand the risk associated with a quality issue. And this machine learning model goes through those thousands of issues and surfaces the 31 issues that carry the highest risk. Also, out of those 31, 5 of them are especially bad because they carry water risk. And water risk on a construction project is a big no-no. Like if there's risk of water infiltration, that's like just everyone panics because if there's risk of water damage and actual water damage happens, if there's a weather event like rain, then that means major rework to fix water-related damage because everyone has to be involved to fix something like that. There's major scheduling delays. So water-related risk is the worst. So what we do is we prevent these 5 critical issues from slipping through the cracks by exposing them in their interface and making it really simple for a project engineer to address those. Similarly, this is a real photograph. This is this is the number of people a product manager or a safety inspector on a construction project has to deal with every morning. And what they have to do is they have to decide after this like all hands big meeting, who do I go and talk with? Like who do I focus on? So what we do for them is we create a prioritized list for all the companies that are on their construction project by how much, and this list is prioritized by how much risk a particular company is carrying. So, and we also expose the factors we think that are important for that risk so that this project manager can go and have a informed conversation and also be able to present actionable items that, hey, if you go and close out those 3 high-risk issues, then you won't show up here. Or if you start closing or addressing things in a faster way, that's a good behavior, and that would take you off this. Similarly, just like a quick introduction of what OSHA is for those who don't know. So OSHA is a US body that's responsible for worker safety on job sites. And OSHA reports that there are 937 construction fatalities every year. And this is on across all industries, this is a high. Like this is much higher than any other industry. So, and OSHA also believes that out of these 937 fatalities, 600 are preventable. 600 can be prevented. So the question we ask is, what can we do on a job site? How can we create software that inspires people to encourage good safety practices and discourage negative safety practices? We also build software for all personas on a job site. So we want to empower all personas with this kind of like machine learning driven information. So here we have something that a superintendent or a project engineer or a project manager would use. And this is kind of like their daily prioritized list. So the same as like when I come to work, before in the morning, I check 2 things. I check like what the muni time and I check the weather. And that informs me, helps me make my morning decisions on how to commute. Similarly, we envision this same way that like when you check the weather, you check the IQ app, and it tells you who should you talk with, and if there is anything that carries more risk than usual that has popped up since you last checked IQ. But we also want to bubble this information up. So we have something for the executives. Here, an executive can see an overall trend of what's happening on their construction job sites, who would they want to focus with, and kind of that red shows like really bad things are happening. That's where you should focus. And that's the breeding lead. Next, I want to talk about something that a very common problem that data scientists face. Any data scientist would tell you that a golden data set is, a labeled data set is golden. And so how do we face the same problem, that we have data sets, but they are not labeled? So this is a particular solution that we use for addressing this problem. And we call it Lucy, for labeling large-scale data sets using human-scale input. So basically what Lucy is trying to maximize the amount of labeled data that we can have while trying to minimize the amount of human input required to label that data. And this is how it works, so more details. Say we have an original data set, and say this data set has 100,000 data points. Now what I want to do is, labeling 100,000 data points is a big project. And not everyone can make that investment to get things started or get the ball rolling. So what we do is we take that data set and we cluster it. Once we cluster it, we go and based on some metrics, we identify the clusters that are above a certain quality. And now we have a list, we have a set of clusters that have clustered really well and are above a certain quality. We take from each of these clusters, we pick out representative samples, and we bring them all together. So now here, we had the original data set with 100,000 data points, and using this process, say we picked out 1,000 data points that capture some amount of variance in the original data, of course not everything, but are kind of representative of the larger data set. So here we are trying to maximize the variance while trying to minimize the amount of data we are extracting out. So say we extract out 1,000 representative rows here. Next, what we do is we have this set of representative samples. We work with our internal experts, and we work with our experts to label this data. And labeling thousands of data points is not a big task. Like that's something I can sit with my colleague and do it in a couple of hours with an Excel sheet, like really easy. So it reduces the magnitude of the work that needs to be done. But the problem at this stage is that, okay, I have a labeled data set now, but it's only 1,000 data points. Can I really trust a model I train against this? It may not capture enough of what I need for this, or it may not be enough volume to train a model. So what we do next is we take this data set, and based on distance metrics, we try and propagate labels to a larger data set that is unlabeled. So based on proximity metrics, we propagate the label to a larger data set. And here what we're trying to do is minimize the amount of, so here what we're trying to do is minimize, so maximize the amount of data with labels while trying to balance that with the variance. So trying to maximize the variance and maximize the amount of data we can propagate while trying to keep our confidence in that propagated label high. And then this kind of a data set can be used for training a model. And this becomes a starting point. So now by only labeling 1,000 data points, I am able to create a data set which captures a decent percentage of the variance from the original data set and can be used for training. So I go ahead, train a model on this, and now I have a good starting point. So this is how we take advantage of the data sets that we already have that are not labeled. But what about the data that's coming in? So in our interface, we expose the high-risk issues. Now say our customer goes in and looks at our interface, and they see a particular issue that has been marked as high risk, but not water risk. So what we enable them to do is go into this interface and find that issue and change it. And if they like, they can add a label, remove a label, or modify a label, and also give us feedback on why they think that is. And this empowers us to build software where we can, so in real time we find out, in near real time we find out the model performance. So we can track the predictions that we are making and what our users are saying, the deviation between the two, and we can kind of get an understanding of when do we need to retrain our models. So, and this way we can also collect labels for new data that we don't have. We can collect labels that we don't have. So actually in this case, this model did pick up the label of water just for the sake of this exercise. I went in, removed that label, and recorded the whole thing. So we understand data really well, and we have developed some of these techniques. So to talk about how we are leveraging some of this data and techniques, I want to invite Charis Kaskiris.
Thank you, Shubham. So Shubham walked you through how we actually generate data sets from limited labeled data sets so that we can actually leverage them for building prediction models. And in doing so, what I'm displaying here is what do we actually show our customers? We effectively show them scores, and then we describe the score for the project. We describe who are the subcontractors on the project and how are they behaving with respects to quality. And then what we also have next to it is data that these scores are based on. In particular, when you click on a particular customer, you also see exactly which factors that are based on the original data set are the ones that are actually driving the score itself. This allows our customers to be able to action by having a sense of who do we go talk to, and why are we talking to them, and what are the things that we can action on, which are the issues that drive the factors. How did we get there? As we'll take the journey backwards and say, we have a lot of data sources, as Shubham described earlier. In our particular case, especially in construction, we have both data that is numerical in nature, textual, also imagery and designs, 3D designs of the buildings and 2D designs. And this allows us to effectively orient the data in space and time. And that way we can actually start understanding what is driving the different types of issues that are generated and how do those relate to the performance of the particular subcontractors. So from this, what we do, we effectively extract features, and what we build from them, well, we have, I would say, a cascading set of models. So certain models, kind of the blue ones, are models that allows us to do augment the data by understanding, well, if you describe an issue in this way, that sounds like a high-risk issue, or a medium-risk issue, or a low-risk issue. At the same time, we can also classify them in categories that are important in construction. For example, if it's a water issue or if it impacts schedule. And then on top of those, we build further factors that influence built-in models for daily consumption, which are, if you think about them as rank ordering systems, that help you understand which subcontractor you need to address on a particular date, given the short-term horizon of what we observe. But then we also have models that deal with, well, how are they actually behaving across the whole project that they're working on? In a sense, also describing their behavior is a behavioral score, which describes, well, how do they actually respond to issues and how fast do they respond and how good is the workmanship they generate. On top of this, you can even do a further higher up model where you actually look at the whole project in itself. And by looking at the broader set, then you can actually understand how is the whole project work. But that also allows executives to be able to see project scores across different projects that happen in the company, and then they can address particular projects when they need to prioritize. Oh, and I'm clicking the wrong button. So why do we do this, and why do we represent all this data? And what I'm going to describe dictates effectively the types of modeling we can use. So we use an evidence-based set of practices and modeling, and that means that at the higher level models that we present to our customers, they need to have explanation codes in them. Explanation codes means that the factors that actually drive them need to be visible to the clients so they can actually understand, not just only understand, get insights, but then most importantly, to trust what the models are telling them. So trust is a very critical component in this business, especially for people who have never done analytics before. If you're going to give them some machine learning and some scoring product, they need to be able to trust that the model is telling them something that is meaningful in the real world. At the same time, we want our machine learning components to be able to trust what the humans are telling us as well. So is this environment where both can, in essence, this is what the evidence-based practice is, which is you leverage the expertise and the data and the research, but then also manage the user expectations and bring them all together into an environment where there is common trust across the components themselves. And the way that we instantiate this is, as I was saying earlier, is you see the risk score, you see the factors that are driving it, and then you drill down and you can actually see exactly which issues are the ones we are talking about, so you can have a level of trust on what the models are telling you. So this is what our data science methodology that we use. It should ring very familiar to anybody who has done data science type of work before. Obviously, data is the biggest pain. Let's get the data in and let's clean the data, set it up in a way that is effectively ready for us to do machine learning against. That was part of the Lucy methodology, is part of the data augmentation. A lot of the risk, the classifiers we use are also in that vein because they actually augment the data in a way that is useful in some manner that reflects the expertise of the projects, of the models we try to build. Then, of course, the second part is like, how do we model this? Feature selection, feature engineering, the different types of models we run. And then which models do we choose, and also do tuning of these models either through cross-validation using different data sets from different customers, or different augmented data sets that we have as well. And that drives what the actual models are that are selected. One of the critical steps that might not be familiar with which is not heavily utilized typically is this concept of having expert validation and always have result verification with clients. This is a process that I think Shubham elucidated earlier too, is we don't only just utilize our customers to help us identify the labeled data sets, we also have them verify that the results that the algorithms generate are correct. And that obviously correct within a certain level of precision and recall, in a sense. And that's where this verification phase goes through. And finally, once we built all these models and we're ready and everybody trusts them, is, well, how do we productize them? So we built them in an environment where we need to have data governance structures that dictate that this is a repeatable process, there is consistency in the data, there's no data shift. We're also going through tracking the performance of the models over time so we can understand if our models are deteriorating, when are they deteriorating, should we change them, when do we retrain? And obviously, by having interactive machine learning, we actually allow our customers to go in on the fly and tell us, no, this is wrong. And typically, if it's something wrong that is with the classifiers, we immediately adjust the models themselves, we adjust the scores themselves. But if it's something about the scores, that has to follow within the model governance structure, which we don't really allow them to change the scores themselves. Now, in order to, and this, of course, repeats itself. It's just like Groundhog Day. Every day, same thing over and over for us and the whole team. In order to instantiate this kind of process, what we opted to do was utilize Spark. And part of the reason we utilize Spark is that it allowed us to bring data close to the computation. And it also allowed us to bring kind of heterogeneous data sources together in one environment where we can actually compute against it. Our world that we live in is basically any flavor of database you can imagine is our products. So we have to ingest from databases. We have data that can come from sensors. We have data that can come from, effectively from user actions. And then images and all these other components. So we had to use an architecture that would allow it to work against them. At the same time, we wanted to be able to do batch mode and streaming types of workloads or payloads from my old days at NASA, I guess. Another part was to have a more integrated way to do analytics on the same platform, basically both the data management part and the machine learning part. And then a smoother transition to production. In a sense, have an environment where the production environment and the data science environments were quite similar in a way that would make the transition of finished models from one environment to the next be fairly less cumbersome. So in order to utilize Spark in an effective way, we partner up with Databricks and have used their environment, predominantly because it streamlined a lot of our workflow and also allowed us to do the kind of things we wanted to be doing, which is, for example, with cluster management and auto-scaling, it allowed us to have a data science team that could scale up the clusters, do the heavy lifting, and then effectively come down. But then this was not exactly the environment that the production environment needed to be. Now, it was similar, but the clusters were different. We could manage it easily through Databricks. They also have workflows between notebooks that allowed us to basically loosely couple our code and being able to build reusable components that can be used across by multiple types of models. There's also visualization support that has been critical. In our case, we work with customers and being able to see the data of each customer in a different way and how to compare them. That was critical component of our workflow. Allowing real-time collaboration in books allowed us to go through our review process. Our teams build models, but our team also kind of reviews the models of everyone, sanity checks, and making sure that analytics are done correctly. Also, the ability to blend code of different flavors has also been very useful for us since we have, our team is kind of broadly skilled. And then, of course, turning this into jobs in a click of a button has been very, very useful for us. In closing, I want to bring back why are we doing all these things and where are we in construction and how do we behave with our customers. Our customers are the center of, we are a very customer-centric set of analytics. We look at our customers' problems and we work with them to effectively help them improve their performance. The way we do this is through their data, and there is a very close collaboration between us, our customers, the data they generate, And then all the work that they do with us in order to classify, verify, utilize, and ultimately trust the data that we build, and they trust that what we build for them is actually useful in their environment. And with that, this is Autodesk. Make anything in construction for today. And thank you very much.
So any questions? All right.
I do have a question. So you mentioned earlier in the BIM 360 like dashboard, you provide your customer a score saying, hey, what's the risk like level of the certain project, right? So I think the problem there is like every time you provide that kind of score, can customer trust that? Like if I get a 95 score, and can you make sure that, hey, my project doesn't go wrong, or like if I get a 60, then is there something wrong, or it's just a false alarm? So how can you do that?
I can answer that. So as I explained earlier, what we would do is when we build all these different scores, we will go back to our customers and actually sit with them and verify that is what we are telling you correct. But we also did it in a retroactive manner. In a sense, we actually built their. So if we would jump into a project that is in flight, and some of these projects take 3 years, we would also score everything that happened before based on these different models on a daily basis for the last 2 or 3 years. And in many instances, the response we would get from them is, oh, you identified the people we fired because of the scores that we generated. So yes, we go through a cycle where we have to verify that these things are running correctly, and our customers are the ones who validate that what we are doing is, what the models are picking is correct. Now, the way we built the features in the first place were in consultation with experts in construction. So the features themselves are components that somebody who's an expert in project management and construction would actually look at those in the first place. It's just the weighting of those is dictated by algorithms, in a sense.
So just to add to that, that's a very valid question. And I think we live in constant fear of the day when these things are not as accurate. And so as I said, like we're constantly validating. And this is like before it's in product and after it's in product. And there have been cases where, this is the benefits of early validation, I guess, is there have been cases where we went to our customers, showed them something, we were all very excited. They came in and they're like, this makes no sense, this is just crap. And they gave us feedback on why they thought that wasn't good, and that like completely altered our thinking. We went back, made some changes again, went back to them, and they're like, yeah, this is starting to make more sense, and slowly like iterating, so kind of just course correcting a little bit and getting there. And we constantly keep doing that, as like Charis also spoke a little bit about model degradation over time. Like if we show something today that's accurate today, like year from now, just because of people who are using this model, these things tend to degrade. And when it degrades, it needs to be, so there are two things that need to do. First, we need to know that it's degrading. And so that's one of the things why we have built feedback into a product. People are constantly telling us that, yes, this is okay, or no, this does not make sense. And this is why I think it does not make any sense. So that's one part of it. And the second is once we understand that what we're predicting and what's the ground truth is diverging enough, that's a good indicator of it's time to do some work.
Hi, yeah, this is really cool, by the way. If you can go back to the Lucy methodology slide, there was that step where you propagate the labels from that smaller set of labels. Mm-hmm. Can you talk about why that assumption is okay? Because I feel like you would lose a lot of accuracy when you do that. And then can you talk about how, a little bit more of the details of how you do that propagation?
So that's a very good question. I was totally expecting that, and so there are certain things I can talk about and certain things I can't. But at the same time, that's a very good question. And yes, what you're completely right about is, or you're alluding towards is, would this be as accurate or comparable to something that was trained against those 100,000 data points? And the answer is no. What we try to do is we try to kind of maximize the amount of variance we can capture while trying to keep our human input low. And so the goal behind this methodology is not to develop something that's very highly accurate, and the moment our customers see it, they will accept it. the goal behind this is to get us a starting point where we have a precision and a recall good enough that when we show it, it would be acceptable. And then the hope is that as people start using it, we keep improving it by building in mechanisms into our software to know like if our models are degrading over time. So that's kind of a strategy of how we leverage something like this. Talking about propagating labels. So this is something that we have so far used with like textual data. And we are now like figuring out ways to leverage this with other kinds of data sets, other data format. So the way we propagate kind of changes between the kind of data you're putting through. Like if you put image data through this pipeline, then the proximity metric has to be different. So here for text, we use like a certain kind of distance proximity metric, which tells us how similar is it to the distance we want to propagate to. And there are a few other things we watch for. Like we watch for certain keywords, and those are more important than others. So there are a few more things that we do while propagation to keep our confidence level high, that when it's propagated, we have confidence in the label.
Hey, construction is no doubt changing rapidly with technology. So no doubt there's lots of new issues that are coming up, new quality issues that for each project might be new to you folks in terms of the data that you might be collecting. I'm wondering if you treat any of these new issues in a particular sort of way, as opposed to some basic things that you might be familiar with, like pipes breaking and concrete cracking, that sort of thing. Especially since you have kind of like a semi-supervised problem, do you do any, in terms of presenting or ranking your scored risks, do you treat these new items in any kind of special way?
So sorry, apologies. Do you want to?
So let me explain how we did this. So we work with an executive team across the industry that is the quality
Council.
executive construction quality executive council. And what they have done is analyze data across their companies. There are about 10 companies together that are some of the largest in the world. And what they did there is identified effectively what were the set of issues that, from a quality standpoint, are the ones that are more critical for them. And what our models are trying to do is detect if, when we classify high severity for them, is based on the notion is this thing going to be, for example, lead to a water problem? And it's not looking for things like water in the text. What it looks like for is there caulking missing from this external window that can have water infiltration? Water and construction are very bad friends. Actually, they're not friends. They're enemies. Water will destroy the building. So in a sense, as an example of that. Now, when new construction issues come in a sense, you haven't, typically in construction, they have been doing this for so long, so there's not that many surprises in a sense. And we don't claim to be capturing 100% of the issues that can come in, but we capture a large proportion of what can possibly go wrong. And that's, so following through this iterative cycle, and as I said, machine learning in this industry is a kind of a new thing. And we built our products in a way that we can actually capture the next generation of problems that would come in and see if we need to address them.
All right. So we're really running out of time. So there's still a lot of good questions. So would you mind to chat offline, and so we can move on to the next speak?
Yes,
Absolutely.
Thank you very much.
Thank you for the understanding. Appreciate it.
Thank you, guys.